I'm curious about like the origin of your method. How did that come about?
Well, I'm trying to think when I first did that, and I think it might have gone back to the 60s, maybe, when I got a consulting job with Raytheon. Raytheon used to do airline reservation systems, and they had what in those days was called a mini computer. It would it would it was a it would fit in a rack that would go against a wall, and you program the thing in assembly language, and we would check to see if our programs were right by single stepping through, because you could push a button on the front of the mini computer to single step one instruction, and you go step by step to make sure it's doing the right thing. And then you get tired of, well, first of all, if you're doing that, then if there's anything wasting time, you're going to know, because you're stepping through it, wasting time and wasting your own time when you want to have lunch. Okay. But so sometimes you get kind of lazy and you hit the run button and then you hit the halt button.
Oh yeah, yeah.
And then you say, well, what the heck is going on now? And so you look at the stack and so on, except computers didn't have stacks in those days. But well, what to
Oh,
do?
that's
So I
going
get,
way back when we didn't even have stacks. Did you sort of come up with your own way of doing function calls, or sort of simulating a stack or something using?
no, I think actual program stacks. See, back in the original Fortran days, if you had a Fortran routine if you had Fortran routine A that called B that called A, you could tell because the lights on the front of the computer would go blank because the thing was in a loop. It was an infinite loop because it
Yeah.
was returning to itself. I know that digital PDP 8s or PDP 10s, I forget, came along, and they actually put a stack into the hardware so that routine A could call routine B, and which could call routine A, and when A returned, it would come back to B.
I feel like I sometimes do that when my stack is too full. Instead of saying stack overflow, I just forget the top parts of the stack. I I digress so many times. I forgot what I was trying to do in the first place.
In those days, there was Fortran, there was Algol, there was Snowball, and somebody along the way said, we want to have functions that can call themselves, like do a factorial. Okay, well, you got to have a stack. And so they said, well, okay, well, in our compiler, we'll have it put in stack. We'll have it make its own stack.
Hard to imagine a time when we didn't even know how to do function calls.
We're
That's
talking, the late 50s, showing my age here. In those days, recursion turned out to be a big deal. But then along came object-oriented programming, and people thought, "Oh, this is so great! Let's teach everybody this."
yeah.
And
I was in college back then. I was at Georgia Tech.
yeah, well,
and then everybody was on the Java train,
Yeah. So go figure.
um, so you mentioned you wrote a book, and it was called like making programs better or something, or making programs
Building is a stupid title. Building better applications.
building
Now when I
better.
read it, I cringe. But the thing is that performance tuning was only just one little part of it.
You started with the performance tuning part, and then does that sort of shine a light on other aspects of programming?
Well, if you look at algorithms like table lookup, you've learned various ways to do it, and there's something called information theory, Shannon information theory, which is just kind of like the original information theory used in coding and telephones and things. And it does a beautiful job of explaining and accounting for the performance of these various algorithms. But there's more than one information theory. There's something called Kolmogorov information theory, where instead of, say, having a set of symbols like 0 and 1, you have programs, say, written for Turing machines. And those programs themselves have a concept of information associated with them. You can say, for instance, that suppose you have an arbitrary string. You can say that the information content of that string is the length of the shortest program that can print it.
The information of that string, I would imagine to print any string, you just loop through the characters and print them out one by one, right?
Well, then the characters themselves have to be somewhere.
Oh, I see. The characters themselves have to be stored in like static memory, usually.
Yeah, you have to take the, you can think of all kinds of ways around it.
I got it. Yeah, I see. I see what you're saying. That you're saying, like, if you're just printing out, for example, the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, you don't have to store all of that because you can calculate it. Or if your output is like the Fibonacci sequence or something like that, then you can calculate, you can compute the infinite series or any kind of.
There's a short program, and since there's a short program that can print it, its information content is no more than that.
Got it. Yeah.
It's bigger than 1 bit because there's no program 1 bit long that can print that stuff.
Got it. Yeah.
Okay. And then, I spent good part of the 70s in the AI lab, and there the idea is your brain is a computer, and you have ideas in your head, and the ideas in your head are like data structures, but those ideas are expressed. A data structure is a language because it contains terms that express concepts. And so the idea is that your people are really good at finding good, concise ways to express the ideas that are in their head. And when they communicate them to another person, they pick words and nouns and verbs and adjectives that convey the ideas in your head. And that language that they're used to express it is closely related to the terms in their head that they use to think about the problem. Okay. So what I look for in a programming language is that I'd like to be able to tell the computer, just as I can tell another person, in a language that closely matches what I'm thinking, so that if I change my mind, if I make a small change in my mind, that should result in a small change to the program that I'm typing.
Oh, I see. Yeah.
Okay, and you can measure that by means of, you can use a diff program.
I see. It relates very much to, even though it sounds very theoretical, but it's, I would say, very much related to practical programming work, because you don't want to have to make huge sweeping changes to your code base every time you have to make a modification to your program. You want to be, and that's, in a way, that's the thing that's challenging about work in the industry is like, what is the correct way to structure your program? Because we want the program to be maintainable in the long run, and maintainable means for any given feature that we have to add to the program, we hope to make the least a small change to it to make that happen.
That's exactly right, and people are not taught to do that, and the result is, like the company I just left, they have mega lines of C++ implementing things that could be done in the ideas in it can be expressed in academic papers. They can write a single equation, saying sum of such and so, and it shouldn't be less than 10 times that much in terms of programming code to accomplish it, but it's 1,000 times. So so the slightest change is something that has to go on the list of things to be done, and it can take months to do it, and so on.
Yeah,
the thing is, if I can continue for a second, so that's why I think designing languages is really important. And when you're designing a data structure, you're designing a language because you're deciding what the terms are, and how they're connected. And there are many ways to implement languages. One of my favorites is just use the preprocessor, the C preprocessor. And somehow in Java, they decided that was a bad idea. What's going on?
You're talking about macros.
Yeah, macros.
Nice.
You can have macros that do all the things that you need done, and so you can write your program using the macros, and it'll be a ton shorter and easier to.
That is hilarious. Yeah, that's how I know the Lisp community is really into that. They even formalize it a bit more, probably, because their macro generators can read the AST and so forth.
You got it.
Yeah,
I heard the Lisp was called lots of irritating single parentheses.
That's true. That's true. It's just too many to have to match up.
But you never have to deal with parsing because it's automatic.
That's true. Yeah, that's a really interesting. I would, if you don't mind.
Go ahead.
Because I'm kind of a noob to C programming. I did a little bit in college, but that's so many years ago. So now that I'm doing more work in C again, like usually I stayed away from macros because I thought that that's kind of dark magic kind of thing, and it's kind of hard to debug. If you make a mistake, it's harder to diagnose and so forth. So I mostly stayed away from it, but recently I made a use of it. I try to use it in the context of error handling.
I don't say go bananas with macros. I'm saying use them carefully.
So I kind of want to get your opinion on a scheme that I came up with for error handling in C. I think it's this one. And see if you think it's or just your opinion on it, and whether you have suggestions for me. Okay, so this is my idea. So the problem like that I wanted to solve was the fact that like anytime you call a function that could potentially have an error, the standard thing to do in C is like you return a numeric error code, and then you expect the caller to have to check the error code, and then the problem with that is I find myself writing so many of these if statements and then a little bit of error handling over and over again. And since I'm coming from, higher level languages like Python, I kind of wanted to have like a cleaner or more terser syntax in general. So I was inspired by one of the something I found on the internet where when I call a function, I wrap it with a macro, which would do a little bit of that error checking, and then and then um, and then in the event there's an error code, it just return one, assuming we're within the context where the function also is going to return an error code. So it sort of just passes on the error code to the current function, and so I get to write little bits of code like this, and then in my larger program, I've been making use of it. It looks like this, where like each one of these steps could have an error code, and I need to do a little check and then do some error handling. And now I just wrap it up with this macro that if there's an error, just return one to signal that there's an error for our function as well. Pass it on, pass the buck. And I felt like that's sort of like a poor man's exception handling in a way.
Yeah.
What do you think of this idea?
I think is a great idea. One of the things you have to face when you do things like this is that you impose a learning curve on the next person who comes after you.
Yep.
And my point is that that's not a bad thing. In other words, if you can shrink your code by a factor of 10 and still keep it quite readable, that's worth asking the person who comes after you to learn something about it. It's because often you get in the programmer rules, you'll say, well, it shouldn't, anybody should be able to come up and step up and look at it and work on it. And I'm saying, well, sorry, but programmers are not monkeys. They have to learn. And it's worth spending the time to educate them.
Yeah.
And part of what you do in the code is you should speak to the programmers that come after you and say, this is how you do it.
Yeah. That kind of issue has been, comes up, and we talk about it at work quite often, of like, we're introducing these sort of smart ways of doing things, but then now that's gonna make it harder for everyone to learn it. There's a balance to strike, I think. But yeah, like when you're doing clever things like this, you should think about, okay, how am I gonna get the other folks on board here? What is a good way? What's a smooth learning experience for them?
So that's where your teaching experience comes in handy, is because you're teaching them.
Mm-hmm. Yeah, for sure. Yep. Thank you so much for your feedback. This has been a lot of fun for me, and I'm glad I was able to show you some of my code. And I appreciate the knowledge that you imparted on me and on other folks on Stack Overflow. I can see.
Well, I appreciate your interest.
Yeah, for sure. Yeah, it's really important technique. I think it almost feels like something that all programmers should know, but for some reason most of them don't. So yeah, I hope more people will learn about your technique and try it out. And I might do more videos about it, like just showcase.
I see it as punching through on computer science, because computer science tends to get stuck in grooves, and this is a way of getting out of that.
Yeah. Get into these echo chambers, right? Yeah. Just try to get out of your own echo chamber, whichever one that is. I think it's healthy to hop from one programming community to another, and then to another, and then perhaps you will see more of the world that way.
All right.
Yeah, learn more different programming languages.
Thank you.
Thank you so much.